Hello all. In this video, we will see a solution for the upload error while using STM32 Blue Pill board with STM32 CUBE IDE. Here we have F103 C8 T6 and then C6 T6 and F401 Black Pill boards. All are clones, and we will be using ST-Link dongle to upload the code. This dongle is also a clone. We will be using serial wire debug pins to upload code. In blue pill boards, there are yellow jumper pins for boot selection, but while using serial wire, we are not going to set the jumpers. We'll be using the SWD mode and connecting V2 dongle when 1-to-1 mode. This is C6 blue pill board, and the other one is C8. We face problem only in the C8 board. And the third one is F401 black pill board. The black pill and C6 we do not face any problem. Only with C8 clone we face the problem. Now let us do the connection, 1-to-1 connection. SW clock, SW DAO, and then ground and 3.3 volt. We'll be using 3.3 volt directly from the ST-Link to the board. Now do not use 5 volt as this device is 3.3 volt. Now plug in the S2 dongle, ST-Link dongle. Now we have to install the softwares. STM32 CUBE IDE and then ST-Link driver 009. Get it from the official website. First install the ST-Link driver 009. Once the driver is installed, if you open the device manager, you can see the under the device manager, you can see STM32 ST-Link is recognized under the device manager. Next, install the STM32 CUBE IDE. Once the CUBE IDE is installed, open the IDE, Integrated Development Environment, and then click on Open New STM32 Project. Now, a new window will open for the target selection. Here, type in the correct ID number of the chip, that is STM32 F103 C8 T6. Select the correct target and then click on finish. Now you have to provide a name for the project. Provide a name for the project, and then others are all default selections. Click on finish. Now the next window will open where you can select the pin configuration and the project settings. Under SYS, set the debug as serial wire, and then against the image, select PC13 as GPIO output. This PC13 is the inbuilt LED of the blue pill board. So select it and set it as GPIO out. You will get a pin symbol on that. Now click on generate code. The CUBE IDE will generate the code automatically for you. So this is the skeleton code. For toggling the LED, you have to feed in some minimum line of code. Now scroll down to while. Against under the while one, that is a never-ending loop, you can feed in your user code. Type in HAL underscore, and then to get the IntelliSense, that is a code completion, you press Control and space, Control plus space. Under the IntelliSense, you can complete the code. HAL underscore GPU underscore toggle pin, and then GPU C, that is the port is C, BC, and pin is 13. And then we provide a HAL delay of 1 second. This is the 2 line of code you have to feed in, and then click on save, and then click build. That is a symbol for build is there. You click on build and then click run. Once you click the run, it will try to upload the code onto the board, but you get error, failed to start the GDB server. That is a GDB is the GNU debugger, and that it is unable to start the server on the target. Now again build. There is no error while building, only while uploading, that is while clicking on run. It is not able to upload code onto the STM32 C8 board, C8 blue pill board. Now let us see the solutions. The first, let us try updating the ST-Link dongle. That is the ST-Link upgrade. We'll try to upgrade it. Click on ST-Link upgrade and click on upgrade window. First it will not open. Try to click reset on the board and then remove the USB and then plug it again back and try again. And once you will get the upgrade, you click on upgrade, it will try to upgrade the ST-Link software, but upgrade is not successful. It says ST-Link is missing. And the next solution, let us try the debug configuration. Under the debug configuration, under debugger, select the debug probe as ST-Link Open OCD. The default is ST-Link GDB Server. Now change it to ST-Link Open OCD, and then reset mode is software reset. Now click on apply and then close this. Let us try this on ST-Link Open OCD. Now click on run, save and then run. It will try to run the ST-Link Open OCD. But here also we get the problem. ST-Link is not recognizable and it is not starting the GDB server. So ST-Link upgrade also failed and ST-Link OCD also failed. Now solution is the STM32 CUBE programmer. This is the only solution. You have to upload code using previously it was called ST-Link utility. Now the upgraded one is called as STM32 CUBE programmer. Get it from the official website and then install it. Open the STM32 CUBE programmer. And at the right hand side you can see ST-Link and then a connect button is there. Click on ST-Link at the right hand side and then try to connect. Click on connect. Now it tries to connect to the ST-Link, but it fails. The reason is, and against the serial number you get one asterisk, that is there is no serial number against this, so it is not able to connect it to the clone ST-Link. Now under the reset mode, set it as software reset, and shared you make it as enable. Now go to the serial number. Against that you see a refresh icon. Click on refresh. Now you get a serial number. So when it is shared is enabled, you get a serial number. Now click on connect. Now the connection is successful. Now click on the plus symbol, that is an open file, and then go to your project window and select the ELF file. There will be ELF and then hex file. If you have set for the hex output, you will see the hex file, but you can select ELF also. ELF is full detailed output, so select the ELF file and click on download. Now successfully the code has been downloaded. Now you have to press the reset button on the hardware. Now the code is uploaded and the LED starts blinking. So successfully we have done the upload. Now let us try the F401 black pill board. Here this directly it will upload. Now let us try with the connection with the ST-Link dongle. The connection is 1-to-1. We are using that is a serial wire debug connections, straight connections, the clock DAO, and then ground and the 3.3 volt. 4 wires for the serial wire debug. Connected to your PC and open the STM32 CUBE IDE, a new project, and the target file will open. Target selection. Here you have to feed in STM32 F103 C8. That is a black pill number. Once the target is selected, you provide a project name and then click on finish. Now the next window, pin configuration window, will open. Here you have to set the sys. Against sys, you have to set it as debug as serial wire, and then you select the PC13 and set it as GPIO output, as it is inbuilt LED for black pill and blue pill. Everything is PC13. Now click on generate code. The CUBE IDE will generate a code for you. Scroll down to while, and under this you can feed in the user code. There's 2 lines of code. HAL underscore GPIO toggle pin GPIO, that is a PC13, is made as output, and then we provide a delay. Same as that we did for the C8, and then click on save. Now click on build. Build is successful. Now click on run. Before that, you can go to the debug setting and set it to the default setting. Under the debugger, previously we have changed it to ST-Link OpenOCD. It should be ST-Link GDB Server. That is the default. And click on OK. Now click on run. The build is successful and the code has been uploaded successfully directly from the CUBE IDE. So unlike C8, this F401 does not have any problem in uploading. It can be uploaded directly from the CUBE IDE. No CUBE programmer, separate CUBE programmer is not required. Same way, let us try the C6 model. Direct connection. Remove the connection from the F401 and connect it to C6. Now open the IDE, CUBE IDE, and then click on new project. And under the new project, the target window opens. That is you have to select the target, feed it as STM32 F103 C6T6, and then click on OK. Now the next pin, you have to provide the name for the project. Provide a name and then click OK. The pin configuration window opens. So under sys, select the debug as serial wire, as we did in the previous cases, and then against the image you select the PC13 and make it as GPIO output. PC13 is GPIO output. Then save this and then generate code. Under the code, scroll down to while and then add these 2 lines of code as we did for the previous models. Add these 2 lines of code and then click on save and then build. Build is successful. Now click on run. The code automatically is being uploaded successfully. So only in STM32 C8 we need STM32 CUBE programmer. For the other 2 models, directly from CUBE IDE we can program. Thank you for watching.